Hi, welcome to online tutorial videos from JCBR Labs. For more information and to download the source code and the model of this video, you can visit us at www.jcbrlabs.org. So, in this video, we will talk about how to do simulation in Matlab Simulink for solar cell, or how to simulate a solar cell in Matlab, and then we'll talk about how to create a PV array from solar cells and then how to simulate the PV array as well in Simulink. And we also provide online training, online tuition classes, and help in technical assignments. We also do freelance projects based on embedded system, machine learning, Matlab, data science, Python, etc. So if you have any such requirement, then you can let us know by visiting our website, which is www.jcbrlabs.org, or you can also mail us at jcbrlabs@gmail.com. So let's start with the solar cell. So it is pretty obvious that you may have heard about solar cell, and it is generally also known as the photovoltaic cell. Solar cell. So it is a device which converts the sun energy or the light which is falling onto it into a corresponding electrical voltage. So if we represent it like a cell, and this shows the irradiance, okay, or we can say sunlight or any light shows the irradiance. So it generates some particular voltage, and if it is connected to a some resistance R, so current also starts flowing through the circuit. Okay, so these solar cells are governed by two specific notation, or they are represented by their characteristics are represented by two values, which are open circuit voltage and the short circuit current. Open circuit voltage, that means when there is no resistance. When there is no resistance, then how much voltage it is providing, right? And the short circuit current is that means when R becomes 0, then how much current is there, that will be the short circuit current. So these are the two parameters for this solar cell. Now this modeling of the solar cell is quite important, because when we talk about a MPPT controller, or we want to design some kind of inverter, or suppose we have a large number of arrays and we want to simulate it to connect to a power grid, so we need to analyze the properties of the solar panel, or how the solar panel going to work in those conditions. So this modeling of solar cell holds a very important property, modeling of solar cell. Okay, so there are several models like single cell model, double cell model, or double diode model, single diode model, modified single diode model, double diode model, or the triple diode model. So you may find several kind of models in the literature, but here we will give a brief about it. So we will talk about a single diode model. So a single diode model is represented by a photovoltaic current, which is IPH, which is generated due to the incident of the solar irradiance on the solar cell, and then it is represented by a diode, and then there is a shunt shunt resistance, which is RSH, and a series resistance. So this is RS, this is RSH, this is our diode. So current flowing through is ID1, ID, or current flowing through this shunt resistance RS, and the final current which is coming out of the terminal is this I. So the equation of the I is, in order to do modeling, the I is represented by I equals to IPH, because all these parallel current are being subtracted from the IPH. So IPH minus the diode current. So normal diode current is given by this I naught e to the power V plus I times IRS divided by A times of VT, and minus 1. It is very easy. So it is normal diode current. the voltage applied across the diode, because this is the voltage, this is the voltage. So the voltage here will be a voltage at this point will be V minus IRS, V plus IRS, because we are going back side. So that is why we are getting this V plus IRS, and then finally minus V plus IRS divided by IRSH. So this is the current, this is the ISH current, the voltage here divided by resistance, and this is the diode current, and this is the total diode. So it is very pretty simple. IPH minus all the current, that we will be getting the value of I. So here we have several unknown parameters generally, which plays a critical role, like what is this IPH, what is this I node, the value of IRS, the value of A. So 1 2 3 4, and one more value is there. So these are the value of RSH. These are the 5 parameters which generally plays an important role in the modeling of it. A into RS into RSH, and the value of I naught. Okay, so these are the values which are generally provided by the manufacturer, and this is the research area to model a PV cell in order to find these particular values. Okay, so we will only do a simulation in Simulink with the built-in simulations. Now there is another model as well. One more thing, that is why this is also known as the 5-parameter model. The single diode model also known as the 5-parameter model. Similarly, we have another model which is known as the double diode model. So in this model, we represent the solar cell by we represent a solar cell with the help of 2 diodes. So if we draw it again, there will be some IPH current, that is the photodiode current, and then there is one diode here, and the another diode is in parallel with it, and similarly there is a shunt resistance and the series resistance. So this is the total voltage which we are getting out, and this is the I, and this is RS, and this is RSH, this is diode 1, this is diode 2. So the current flowing through it is ID1, current flowing through it is ID2, and the current is ISH. So the total current coming out of it simply will be IPH, this one, minus this diode current, and this resistance current. So let's say this diode current is IO1. So it is IO1, and the e to the power simple diode current equation V plus IRS divided by A1 times VT minus 1, and then minus another diode current IO2 into e to the power V plus I times RS divided by A2 into VT minus 1, and the minus this one I times this parallel current ISH, which is given by V plus I times RS divided by RSH. So these are very pretty simple. Total current minus all these parallel currents, and that is the current of this I. Right. So now we have here 7 parameters which are unknown, which are IPH, IO1, A1, RS, A2, and then RSH and the IoT. So there are total 7 parameters in this case which are unknown. Now, which I forgot to mention here, VT is the thermal voltage which is given by KT by Q. Okay. So this diode voltage is obviously a thermal temperature dependent, which is the terminal voltage of the diode. So it is given by this KT by Q. So this is how these are the basic equations of the solar cell, which you should know as a basics of it. Okay. So we are now we will move forward in order to create a simulation model in Simulink. One more thing is there, we are not here using we are not writing mathematical equations in order to do this simulation. We are using a built-in solar cell. Okay, built-in solar cell model in Simulink library. Okay, so let's open Matlab. Okay, so let's open Matlab and go to the Simulink. Okay, let's create a new model. Now we have a sim space toolbox in which this solar cell is being given. So first of all, we need to search for a solar cell here. Solar cell. There it is. Alright, so double click on it, you will find it is represented by the short circuit current as I mentioned, and the open circuit voltage, and is the kind of irradiance at 1000 watt per meter square. We were getting these values and the quality factor. Similarly, from here you can change the model by equivalent circuit parameter 5 parameter model or the 8 parameter model, or by short circuit output current voltage of 5 parameter model. So you can change this particular model by any means, and then you apply and then OK. So it has three terminals, one is irradiance, one is positive terminal and the negative terminal. So in order to apply irradiance we need a constant. Okay, prior to constant let's put some converter because we are doing a simulation sim space, so we need converter from sim space to simulation Simulink variable. Okay, so or physical this is known as PS to S converter, which converts physical signal to the Simulink signal. So these terms are known as the physical signal parameters. That is why we need this converter. Now we need a constant sim escape constant. Okay. Here we have PS constant here. So we will connect it. And another thing, we need a current sensor in order to read the value of current, and we need a voltage sensor as well. Okay, here we are. And then let's put some resistance. Okay. And then we need a solver configuration. And we need a ground as well, so that is the for reference purpose. So electrical reference, yes. So I hope these are fine. So yep. Now let's connect. We connect the irradiance to the solar cell. Okay, and if we double click on it, we can put a value of the irradiance. So let's say 1000 watt per meter square. Now it is should go to the current sensor. Okay, and then we will apply resistance. Right, so current should flow through the resistance, and then we connect it to this one, and we will be measuring the voltage across this resistance. Right, so we will be measuring the value of this current sensor, so we need some point in order to display the value. So go to the sink and display, so that we can display the value of current. Similarly, we needed to display the value of this voltage sensor, so we need one more this, yes, and then yeah, that's fine. Now we need to connect the solver configuration as well, and the reference circuit, electrical reference. So that's it. Now let's save it. Let's save it on desktop. Make a PV cell simulation. Okay, let's save it. So now, okay, this resistance has some value ohm. First of all, let's simulate it without having resistance, so that, as we mentioned, these values are given like open circuit voltage and the short circuit current. Okay, so let's simulate it. Okay, we can simulate it for 1 second as well. So let's run it. Yeah, so it is a open circuit voltage of it. Now if do a short circuit means this point will go directly to this one. Yep, now it is short circuited. Now we go to it, we'll get the value of current. Okay, what is saying, the value is the voltage point is, yeah, so its short circuit current is 7.34 ampere. Now if we put a resistance here, so depending on the value of resistance, the current and voltage will vary. So we apply it now. So for 1 ohm resistance we are getting a value of voltage 0.59, that has decreased, and the value of current 0.596. Now we increase the value of resistance to 1 kilo ohm, so it is like a open circuit voltage because resistance is quite high, so voltage 0.6 and current has been reduced to 0.6 milliampere. Okay, so this is how we can simulate a solar cell in Simulink. Okay, now we'll talk about PV arrays. Okay, uh, because as we have seen, solar cell gives a very less amount of current, so we need a combination of all these things in order to get the desired amount of value or the higher value. Okay, so the PV modules or the PV array, if we talk about it, and these are nothing but these are the series and parallel combination of solar cells. So depending on our voltage and the current requirement, we connect these solar cells either in series or in parallel. Let's take an example. Let's say we have a one cell, right? So it is similar to the battery analogy. If we have a one cell and it is providing a radiance and it is providing a open circuit voltage of 0.6 and let's say short circuit current of 6 ampere, right? Let's say it providing, and now if we connect these cells in an array or in a series, right? Let's say we have connected these three in series and each one is irradiance is being provided, and we make a block of it. Block means like this is a complete cell. So here at the output terminal, or this complete, this plus minus, so this VOC will be simply 1.8 volt because voltage will be added, and the short circuit current will remain same, let's say 6 amp, right? So it has become one module or one PV module. Similarly, we can connect these we can say a PV module, and uh, it is an example of three cells are connected in series. Similarly, we can have a combination like we have these 1.8 volt and 6 amp current modules, which is this one, which is made up of three cells, right? So we can have these three different modules in a series, and then each one is having 1.8 volt 6 amp and 1.8 volt 6 amp, and all these are connected in series. Okay, so this total circuit Now this total combination will generate 5.4 volt as open circuit voltage, and the short circuit current will remain same. Similarly, suppose if we want to increase the short circuit current, so what can we do? We can put these cells in a parallel combination. Okay, so all the positives are connected to each one and the negatives are connected to each other. So this was the series combination of the same cell. So again it is, let's say, 1 volt 6 amp, 1 volt 1.8 volt 6 amp, and 1.8 volt and 6 amp. So the total in this case we will be getting like VOC will be 1.8 volt, and the total short circuit current which will be added of these three, that means the 18 ampere. Okay, so similarly, remember each this module has three cells in it. Okay, and each cell has this requirement. So this is how this PV array or the PV modules are made. These are just the series and parallel combination of PV cells. We create one module, and then in order to create a larger voltage and ampere short circuit current module, we create such small PV modules in a again series and parallel combination. Okay, so this is how these PV modules are created. And similarly we could have series parallel combination if we want some other requirement of current and the series voltage. So now we will learn how to create in Simulink. Okay, so let's open Simulink and let's create another one, a new model, and we need most of all these things. Okay, so let's copy and then paste here, because ultimately those are the combination of series and parallel combination of the solar cells. Okay, so here we are, and then let's first save it with the name of let's say PV array. So what we want let's say 1.8 volt, 1.8 equals to as a VOC, and 6 amp as a ISC. Okay, so our module solar cell is same. Okay, it is 7.34 volt. Let's change it to 6 amp. Now, so what we need to do, we need to create three panels in series. So let's put it some downwards. So let's create a 3 solar cell. Each should have connected to the same irradiance, because only then each one will be providing the similar voltage, and then negative this connect to the positive, and then yeah, this is. So you may be getting some problem here, so let me show you the circuit diagram again. Yeah, here it is. We have connected the reference. The only thing which we have changed, we have connected now 3 cells in series. So it is a kind of single solar cell which we have made. Okay, so let's zoom it up a little bit. Yep. Now similarly we are going to measure the current and the voltage, similar resistance. So first let's make it a open circuit test. Okay, so let's see the open circuit voltage of this cell. Yeah, so open circuit voltage is 1.8, right? And now let's create a short circuit current. Find the short circuit current. So we have short circuited. In the case voltage will be 0. So yeah, it is showing us 6 milliamperes. So we have created a module with the specifications of VOC of 1.8 volt and short circuit current of 6 ampere. With three different solar cell connected in series. Each solar cells have a different specifications. So let's connect this resistance in series, and let's see a value. Let's say on 1 kilo ohm how much current or voltage we are getting here. We are getting 0.6 ampere, 0.018 ampere. And let's put some ohm. Yeah, so this is how we can simulate the solar cell and solar array. So if you have any larger requirement for your simulation work, so you can change it to corresponding values. So we can also combine it, and we can also make a subsystem. Let's create a subsystem. Create subsystem from selection. Okay, so this is a solar cell panel which has these three requirements. Now let's say we want a larger amount, so let's create a copy of these subsystems. So each subsystem was providing 1.8 volt short circuit current, and now let's create something bigger. So this was the negative, so negative is going to the positive of it. Okay, so let's okay, similarly it will go there, and then this will be connected here, right? So one point here, these three panels, and each containing 6 solar cells are connected in series. So these three subsystems are connected here. Now let's see how much of open circuit voltage or the short circuit current which we are getting. Because we have connected series, short circuit will remain same. There will be only a difference of the open circuit voltage. Now open circuit voltage has increased. So this is how we can create a larger subsystem, each comprising of series and parallel combination of this solar cell. So I hope you like the video and you understand a lot from this video. And if you have any comment or any suggestion or any requirement, then you can let us know by commenting below this video. But again, we also provide online training, technical assignment, help in technical assignments, and we also do freelance projects based on embedded system, Matlab, machine learning, etc. So if you have any such requirement, then you can let us know by contact us through our website, which is www.jcbrolabs.org, or you can also mail us at jcbrolabs@gmail.com. In our upcoming video, we will be talking about how to create a IV characteristics of a solar cell and then solar panel. Okay, so that's it for this video. Thank you.